Hi dan Assalamualaikum and very good day to all the panelists, Dr. Hamizah binti Muhammad Nasir and Technologist Muhammad Fauzi bin Zakaria. My name is Nur Amirah Hana binti Azmi with metric number DE180093. So today I will present final year project 1 with entitled The Development of Printed Circuit Board PCB Milling Machine. This project was supervised by Technologist Dr. Muhammad Afif bin Ayub. There will be 4 parts in this project. Firstly, the introduction. Secondly, literature review, the methodology, and lastly, the expected result. Why this project will be chosen? Due to the rapid growth of technology, the usage and the utilization of PCB in modern consumer product and electronic device were increasing. Traditional method of PCB, such as etching machine, take a lot of space, long period and required a high cost. By using PCB milling machine, users can produce PCB in their home faster, environmentally friendly, and also maintain the high accuracy. User can also produce directly from the design phase to the implement and testing their circuit design. This innovation will reduce time for prototype and product development, and user will no longer depend on outsourcing. A desktop PCB milling machine is proposed with capability to use same as traditional method to reduce development expenses and complexities. 3D printer motherboard and touch screen display will be used. The motherboard will be using latest Marlin V2.0 firmware, which is meant for 3D printing, but the program will be modified to cater for the PCB mining requirement. The front of this machine will be designed in SolidWorks before it gets ready to the 3D printing. Next, conventional desktop PCB milling machine can obtain from less than 300 USD to more than 3,000 USD. A commercial viable machine that comes with onboard liquid crystal display or LCD for the user interface is almost non-existent. Then, we developed the desktop PCB milling machine to counter this method. User can save multiple files in the SD card, tune the machine on the go, and make the machine working standalone without having to connect a computer. Therefore, the objective is to design and fabricate a desktop PCB milling machine and to implement the electronic control of PCB milling machine using 3D printer motherboard. Okay, next, there will be 7 project scope. Firstly, the SolidWorks will be using to design the structure of PCB milling machine. Second, Marlin V2.0 firmware will be utilizing to control the machine. Third, the mainframe of PCB milling machine will be 3D printed to create custom shape and size apart from saving on prototyping costs. Fourth, the controller of PCB milling machine will be using XKR 1.5 version motherboard. Next, a touchscreen display will be implemented by using TFT35 LCD touchscreen display version 3.1. The next part is stepper motor will be using to control the gantries. And lastly, the prototype of PCB milling machine will be developed up to the movement of the gantries due to the time budget constraint. Additionally, the component for the spindle head will be left out as well for future development. Second part is the literature review. We explain the previous research on CNC machine and current PCB milling machine. Based on the previous research, most of the CNC machine consume high power and has a low accuracy. The Z-axis also not very rigid and it causes vibration. It cannot fabricate in digital and not portable machine. It takes time to find right location on photo and it works slowly and at a huge speed. As you can see here, there's a lot of current PCB milling machine, but there is no LCD come together with the machine. This will lead to difficulties to the user for the engraving process. To solve this issue, this project will develop a PCB milling machine to come with LCD to make the process more easier. For the methodology part, they will be explain the project planning, hardware design, and also software design. This is a project planning to accomplish the project. It begins by designing the machine and frame of PCB milling machine in SolidWorks. The frame will be printed by 3D printer and need to assemble the development of PCB milling machine size. After all the process complete and meet the requirement, it will assemble in the electronic component and will be modifying throughout the milling firmware. This machine will be tested on the LCD touchscreen display and the gantries movement to check whether it meets the milling machine requirement and work successfully or not. If not, the troubleshooting process will be done. The automated in hardware design, which is machine construction and electronic components. The machine and frame of PCB printer will be designed using SolidWorks software. This is because SolidWorks has a searchable database of 3D printer with available information, as well as the ability to generate 2D slice data from highly quality solid geometry rather than tested file and save into the DMF format. As you can see here, this is a draft of body design of PCB milling machine. This machine will develop for target workable area. It will set up to 120 mm times 120 mm as the effective area of a maximum size of PCB tracking. There are several electric components will be used in this project design, which is same as 3D printer. This is because the PCB milling machine will be designed according to the 3D printing machine. Thus, by using the same electronic component will make the assembly process more easier, precise and faster. Alright, firstly is NEMA 70 stepper motor. It is a hybrid stepping motor and generally used in printers and machine also as a cutter. This stepper motor used for rotating movement, as it will move the X, Y and Z axis according to the instruction given. As you can see the picture, there's a seat coil that is used for the movement. Alright, secondly, the SKR mainboard version 1.5. It is a 32 3D printer motherboard that using the main frequency 100 MHz ARM level Cortex M3 as the main control chip. The performance has been greatly improved by equipped with highly modular and open source firmware Marlin 2.0. It's convenient for the user to DIY and the secondary development. By developing PCB mining machine, large storage is really needed so that to store more data, it can be upgraded on configure the firm to the SD card, which is simple, convenient, and also efficient. The next one is the FT35 LCD touchscreen display 3.1 version that has two working modes, which are touchscreen mode and also 128864 LCD that can be selected for the higher compatibility SD card. It has two printing method, which is using SD card and also USB flash drive printing. This method is helpful to print the PCB design as it can directly from computer or save in SD card and make it as a possible printer. As a conclusion, the FT35 LCD touchscreen is a good combination with SKR mainboard version 1.5 to execute the PCB printing process. And lastly, the best part of this machine, it has the Trinamic TMC2209 motor driver. It is an ultra silent motor driver IC for two-phase stepper motor. It is designed to ensure noiseless operation, maximum efficiency and best motor torque, and highly competitive solution. It has been widely used in the cell cope technology for silent motor operation. So by using this motor driver, it will implement the noiseless operation during PCB printing. Next, for the software design, the system will be using SKR mainboard version 1.5 as a controller platform with the Marlin firmware 2.0 version as a system to conduct the printing process. The data from G-code Marlin will be transmitted to the controller. The G-code will give instruction on where to move, how fast to move, and through what part it will move. There are three axes which are X, Y, and Z, which operate followed by X stepper motor will be moved left, Y stepper motor will move front, Z stepper motor will move up and down as the given dimension. The software design, it will be using Marlin firmware version 2.0. As you can see the part flow above, firstly is the Marlin version 2.0 and transmit the data to the controller board, and lastly for the printing process. Marlin runs on 3D printer mainboard, managing all the real-time activity of the machine. It coordinates the heater, stepper, sensor, light, LCD display, button, and everything else involved in the printing process. And lastly, for the expected result, this project will be designed as shown above. This is a prototype of a desktop PCB mining machine that is equipped with LCD, and it is expected to be constructed at the end of this project. The gantries were expected to move in height precision and also in height accuracy. This machine will develop for the target workable area, and it will be set up to 120 mm as the effective back of the area of maximum size of PCB tracking. Next, we move to the demonstration. As a conclusion, I strongly believe the objective and the scope of this project can be achieved successfully. This is because both of the objectives has been achieved in implementing and designing PCB mining machine. Furthermore, the first step of project planning and the first step of project scope, which in designing the SolidWorks, were actively in progress. That's all from me. Thank you and Assalamualaikum.